Hey Chemistry, Mrs. KJ here, going over 2.11, the Bohr atom. Niels Bohr model of the atom will be important to your study of chemistry. That's kind of an understatement. It's going to make a huge difference in how you do in this class. So, as always, when you get stuck, when you have questions, come see me. In this lesson, you will learn about one more model of the atom. Niels Bohr's model places electrons in discrete energy levels or orbitals around the nucleus. The Bohr model is very useful in high school chemistry. And they say high school chemistry because once you get more advanced, you'll learn that it's not perfectly accurate and there's a different model, but for everything we're going to do, this is our number one go-to model. Goals for this lesson: describe the concept of electron orbitals as expressed by the Bohr model of the atom. Explain how quantum mechanics can help in understanding the ideas of discrete electron orbitals. Define valence electrons. All right, atomic models. Outer electrons are named valence electrons. Crazy, crazy, crazy important vocabulary word. Valence electrons. The electrons occupying an atom's outermost energy level, or electron shell, which determines the element's reactivity. So the whole reason that an element is going to react or not has to do with how many valence electrons it has, or in other words, the electrons in the outermost shell. Atomic models developed by Bohr introduced electron orbitals and energy levels. So there's your study guide. The model of the atom has changed over time. Our knowledge of the atom has gained systematically over time. As you may recall, J.J. Thomson suggested a plum pudding model for the atom. In this model, negatively charged electrons were swimming in a sea of positive charges. Ernest Rutherford, with his gold foil experiment, confirmed that there was a centralized nucleus. The Rutherford model was one in which the electrons moved randomly around a central nucleus. Rutherford concurred, after his later work, that the electrons were located outside the nucleus. Neither of these scientists described the electrons as being in a specific locale outside of the nucleus. All right, so chemistry timeline. Dalton's back here. We have Thomson, Rutherford, Chadwick, and Bohr. You can see all this is happening close to the early 1900s. Perhaps I have found out a little about the structure of atoms. Niels Bohr wrote that in a letter to his brother in 1912. Bohr was a student of Rutherford's in the early 1900s. He believed that Rutherford's model needed some refining. New advancements in chemistry, as well as expanded knowledge of the atom, led him to his conclusions. In 1913, Bohr changed the model of the atom. Most of his changes were based on new ideas about how atoms absorb or give off light. The absorption or emission of light is related to how an electron moves, and thus provided Bohr with key data for his model. So Bohr's model of the atom refined the model developed by Rutherford. Bohr suggested that electrons are found in distinct paths around the nucleus. Imagine the nucleus as the sun and the electrons as the planets. In the same way, Bohr's model confines an electron to a distinct orbit around the nucleus. Each of these orbits is a certain distance away from the nucleus. Electrons in the orbits farther from the nucleus have more energy than those closer to the nucleus. These orbits are usually called orbitals in chemistry. Equivalent terms include energy levels or shells. Bohr's model assumed that the electrons are found only in these specific orbitals around the nucleus, rather than being randomly distributed around the nucleus. By contrast, older models had no specific location for the electrons. So the planets, they're saying, okay, we pretend that they have perfect circular orbits around the sun, and that's the same thing that we're saying for the electrons. However, every planet has its own orbit, whereas the electrons share orbits or orbitals. All right, let's look at our notes. Bohr's model, an atomic model that shows the electrons are found in discrete orbitals around the nucleus of an atom. So orbital, an area around the nucleus of an atom that contains one or more electrons. Energy level, regarding electrons, stable state of energy and configuration of electrons as they orbit the nucleus of an atom. Basically, for as much as we need to know for this class, shell, orbital, electron cloud, energy level, they're all the same. It tells how far from the nucleus the electron is. And that's really the main idea. So how far the electron is from the nucleus. and it is a set amount. So in that regards, it is like thinking of the planets going around the sun. Electrons in the orbits farther from the nucleus have more energy than those closer to the nucleus. All right, and I'm going to change this to orbitals because that's how we refer to it for chemistry. Electrons in orbitals farther from the nucleus have more energy. Think of the nucleus as mom. Which kids have the most energy? The ones sitting quietly next to her, or the ones running around in circles almost out of her reach? Okay, those naughty little electrons running way out there going around and around and around, right? They have lots of energy. They're going crazy. Versus the electrons that are close to the nucleus, which are still moving, but they have less energy. Also under orbitals, I want to add that the first orbital can hold 2 electrons, and that's going to be important for when we do our drawings. And for our purposes, for Bohr diagrams, the other orbitals can each hold 8 electrons. So you fill up one orbital before you go to the next one. All right, and we'll talk some more about that in the upcoming slides. Here are some examples of Bohr models for specific atoms. In the How Many Electrons activity, there are 4 atoms, each represented by Bohr models. Each atom is electrically neutral. It has neither a positive charge nor a negative charge. For each atom in the activity, answer the questions. All right, how many electrons does this atom have? Well, we know that it is boron, and so it has 5 protons. It's going to start out with 5 electrons. How many electrons are in the orbital closest to the nucleus? All right, so in our first orbital, there are 2. Once you have 2 in that first orbital, then you can put the remainder in the next orbital. There's only 3 that are left. How does the energy of the electrons differ from the innermost orbital to the outermost? In other words, which one have more energy? The energy increases. There's more energy as you get further away from mom, and you can run around like a little crazy kid. Mom, in this case, being the nucleus. All right, and let's go ahead and look at this one. Potassium. How many electrons does this atom have? It's electrically neutral. It has 19 protons, so it has 19 electrons. How many electrons are in the orbital closest to the nucleus? Your first orbital can only hold 2. How many will the next one hold? 8. How many does the next one hold? 8. How many are left over for the outer one? Just 1. And that's our last question. How many electrons are in the outermost orbital, or how many valence electrons are there? 1 valence electron, or 1 electron in the outermost orbital. How many electron orbitals are surrounding the nucleus? Okay, so now you're counting the orbitals. 1, 2, 3, 4. How many electrons does this atom have? Krypton has 36 protons, so it has 36 electrons when you start out. All right, let's start at the inside. How many electrons go in the first shell? 2. How many in the next shell? 8. Now usually it's 2, 8, 8 like that, but this one's an example of one where it's a little bit different. But for what we're going to be doing, we're going to use the 2, 8, 8 model. So how many electrons are in the outermost orbital? 1, 2, 3, 4, 5, 6, 7, 8. And that answer will be the same even if you do the 2, 8, 8, 8 method. How many electrons are in the third orbital? And how does the energy of the electrons differ from the outer to the innermost? So the energy decreases as you go in, and there's 18 total in that shell. In Bohr's model, electrons have a certain set amount of energy. As you have seen in the Bohr atom, each electron is at a specific or discrete distance from the nucleus. Each resides in one of a series of fixed orbitals around the nucleus. This means that each electron in a specific orbital has a fixed amount of energy associated with its movement. So, for example, what they're saying by this is these electrons are stuck at this distance and they have less energy then these electrons stuck at this distance. So not only are they stuck at a distance, when they're at that distance, they're stuck at a certain amount of energy as well. An orbital is also called an energy level. Electrons in a Bohr atom exist at specific energy levels. They cannot reside between energy levels. Generally speaking, electrons residing in orbitals closer to the nucleus are at a lower energy level. Electrons in orbitals farther from the nucleus are at a higher energy level. It is possible for an electron to change orbitals or energy levels, but that change has to be a very specific change. An electron would have to gain or lose exactly the right amount of energy to change energy levels, or, in other words, to move to a different orbital. The more energy an electron has, the farther away from the nucleus that energy orbits. So you can see as I get more energy, it's farther away. But it's not going to just jump little bits. It's either going to be at one orbital, or it's going to jump up to the next orbital, or the next orbital, or the next orbital. So it's very specific in the jumps. For an electron to move farther from the nucleus, it must absorb energy. Well, that makes sense. If I need to have more energy to be out here, I have to take in some more energy to have the energy to be able to jump out there. An electron in an orbital closer to the nucleus has less energy than one in the outer orbital. Recall that each electron in a particular orbit has, and therefore must have, a certain amount of energy. In order for an electron to jump to a higher energy level, it has to absorb energy from somewhere, or get more energy. This extra energy comes from the environment. Many times an electron can get the extra energy from light in the environment. You may recall from biology that organelles called chloroplasts are responsible for making the energy in a plant cell. Chloroplasts absorb energy from sunlight, causing electrons to move to higher orbitals within the plant cells. So it's kind of cool to know why that happens. This increase in electron energy is necessary for a plant cell to live and maintain itself. All right, so click a photon to have electron absorb it, gain energy, and jump to a higher orbital. So here it is in the orbital. We'll throw in a little bit of energy, and it jumps a little bit. Okay, so throw in a little bit more energy, and what's going to happen? Ooh, it jumped up to the 4. All right, what do you think is going to happen if I add a lot of energy? With enough energy, the electron escapes the pull of the nucleus and the atom ionizes. So I made an ion. And what would the charge of this ion be? It would be +1, assuming that I started with just the 1 electron. So let's see, we started, now this time I gave it all that energy when it was at the first orbital, and it jumped to the 7th orbital. So you can see that it's always going to jump to another orbital. It does not go in between the orbitals. That being said, the orbitals are not really there like a highway. It's just the path that it follows, just like the Earth does not travel on a racetrack around the sun, but we still draw it in all the pictures to show the path. It's the same idea. And so I added to our notes, if electrons absorb the right amount of energy, they can jump to a higher energy level, or a higher orbital. For an electron to move closer to the nucleus, okay, so now I'm going closer in, it must release energy. Just as an electron can move to a higher energy level, it is also possible for one to fall to a lower energy level. That would place the electron closer to the nucleus. And electrons in orbitals closer to the nucleus have less energy. When an electron drops to a lower energy level closer to the nucleus, it emits or gives off energy. Have you ever seen the glow of a firefly on a summer evening? The fluorescent light given off by fireflies is a result of electrons emitting energy as they move to lower energy levels. Also cool. The falling electrons give off a yellowish-green light as they release energy to the environment. So now we are going to release energy, and you can see as it's releasing energy, it's getting closer and closer to the center. If I release a higher amount of energy, it has a larger jump. So if I release a lot of energy, it falls all the way down to the center. This is the lowest amount of energy an electron can have and still be in an orbital. If electrons emit or give off the right amount of energy, they fall to an orbital closer to the nucleus. and we'll pick up in the next video.